Alright, we're continuing graphing our quadratics using standard form. So we're trying to put together all of the skills that we learned in the first video into graphing some quadratics. So first off, we want to know whether our graph opens up or down. Well, this opens up because x squared is positive. Our vertex, that's our hard part. We need to start with our formula. X equals negative b over 2a. B is 6, so we have negative 6 over 2 times a, which is 1. And this works out to be negative 3. Once we have our x, we just plug that in to find our y. So our y is our x, which is negative 3 squared plus 6 times negative 3 plus 8. So you take a couple seconds, and again, we just are plugging in everywhere we see x, we're plugging in our negative 3. So this ends up being 9 minus 18 plus 8, which works out to negative 1. So we've got our ordered pair, negative 3, negative 1. Now, do we have a max or min? Well, if we open upwards, we have a minimum value. Our axis of symmetry, x is always equal to whatever our x value is. So whatever our x value is, that's what we got. Our y-intercept is always 0c. In this case, our c is 8, so 0, 8. Once we have all of our data here, we are just going to plot everything we know. So we're going to plot our ordered pairs first. So our vertex, negative 3, negative 1. It's one spot. Our axis of symmetry, 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. A little bit off the graph. And we're also going to plot our axis of symmetry. Our axis of symmetry is a vertical line going through here at negative 3. Now, line of symmetry lets us flip things across the line. Now, our ordered pair down here for a vertex doesn't really have anywhere to flip to, but our y-intercept can. If it's 3 to the right, we're going to flip it 3 to the left. Here's our other point. And then we just connect our dots and try our best to actually hit them in a parabola shape. So that was semi-successful. That's the main idea. Let's try one more here. For 2, it's negative, so it opens down. Our vertex is negative b, which is 4 over 2, and a is negative 2. So this ends up being negative 1. So our vertex is negative 1 comma something. We just got to plug it in. Negative 2, negative 1 squared minus 4 times negative 1 plus 3. Follower of operations, negative 2 plus 4 plus 3, giving us 5. Opens down, so we have a maximum. Axis of symmetry, x equals negative 1, because that is the x-coordinate of our vertex. Our y-intercept is always 0, c, and c is 3. Plot everything we know. Negative 1 up 5. 1, 2, 3, 4, 5. And then we plot our y-intercept of 0, 3. 1, 2, 3. Our axis of symmetry. So our vertical line going through there at 1. We flip our point across. So this point here at our y-intercept gets flipped across, right across the line of symmetry, and then we do our best to connect the dots. All the problems are going to follow basically the same format. Our domain for each of these is all real numbers. The domain for any parabola is all real numbers. And our range for the first one is just bottom and top. Negative 1 on up to infinity. And these are always actually going to be brackets for our numbers because they get there. So range for the second one, negative infinity, up all the way up until we hit our 5. And that's basically it.